We decided to validate the scientific principle Ohm's Law. Ohm's Law is a relationship between the voltage, current, and resistance in a circuit. Voltage is equal to the product of resistance and current within a given circuit. Resistance can be treated as a constant of proportionality, therefore voltage is directly proportional to the current in a circuit. We began our project by testing the voltage of each battery separately, and then putting the batteries together in series and testing their voltages to see how much the voltages varied.
The average of each battery separately was about 1.64 volts. Of 2 batteries was 3.24 volts, of 3 batteries was 4.87 volts, and of 4 batteries was 6.51 volts.
Electricity. Our first experiment tested current. We did 3 separate trials using a 10 ohm resistor and 3 different voltages. For a voltage of 3.24, we calculated a value of 288 milliamps using Ohm's law. Our experimental value using the same voltage and resistance was 287 milliamps, giving us an experimental error of 0.35%. For a voltage of 4.87, we calculated a value of 429 milliamps using Ohm's law. Our experimental value using the same voltage and resistance was 410 milliamps, giving us an experimental error of 4.43%. For a voltage of 6.51 volts, we calculated a value of 573 milliamps using Ohm's law. Our experimental value using the same voltage and resistance was 533 milliamps, giving us an experimental error of 6.98%. The errors in the second and third trials can be attributed to the overheating of the 10 ohm resistor, which caused its resistance to increase.
We then repeated the experiment using the 100 ohm resistor with the same 3 voltages. For a voltage of 3.24, we calculated a value of 32 milliamps using Ohm's law. Our experimental value using the same voltage and resistance was 31 milliamps, giving us an experimental error of 3.13%. For a voltage of 4.87, we calculated a value of 48 milliamps using Ohm's law. Our experimental value using the same voltage and resistance was 47 milliamps, giving us an experimental error of 2.08%.
For a voltage of 6.51, we calculated a value of 64 milliamps using Ohm's law. Our experimental value using the same voltage and resistance was 62 milliamps, giving us an experimental error of 3.13%.
We then performed a second experiment to test voltage. We used a 10 ohm resistor with 5 milliamps of current, which gave us a calculated voltage of 0.051 and an experimental voltage of 0.051. With the same resistor, we used 10 milliamps of current, which gave us a calculated voltage of 0.103 and a measured value of 0.103. Finally, with the same resistor, we ran 20 milliamps of current. This gave us a calculated voltage of 0.204 and a measured voltage of 0.204. We repeated this experiment using a 100 ohm resistor. With a current of 5 milliamps, our calculated value came out to be 0.512 volts, and our experimental value was 0.516 volts. This was an error of 0.78%. Using a current of 10 milliamps, we calculated a voltage of 1.00 and an experimental voltage of 1.04, which gave us an experimental error of 4.0%. Using a current of 20 milliamps, we calculated a voltage of 2.05, and our experimental value was the same, which gave us some pretty awesome results. Our last trial involved a 1000 ohm resistor. With 5 milliamps of current, it gave us a calculated voltage of 5.04, which also matched our experimental value. Next, we ran a 10 milliamp current, which gave us a calculated value of 10.3 volts, which then again matched our experimental value. Finally, we ran 20 milliamps of current through the circuit, giving us a calculated value of 20.2 volts, which yet again matches our experimental value, thus proving Ohm's law.